Ladies and gentlemen, boys and girls, welcome to this e-talk. Today we are in coronavirus times, so we are not doing this physically. I was happy to join the previous presentation about digitalization. So now this one will go into a totally different direction. This is, I'm going to describe a business which is still very much brick and mortar, still very much engineering, and still very much metallurgy. So before we start, just want to introduce myself a little bit. You guys are all celebrating 80 years of your department. So congratulations to all of you, to the professors, to actually the founders who started this college and this department, and to all you students who are part of this 80th celebration. This reminds me, exactly 41 years ago, in 1979, I entered college, like most of you are today, to become a metallurgical engineer. I was just thinking, what do I remember of college? So I remember engineering drawing. I remember phase transformations. I remember dislocation theory, steel making. 4 years later, I completed the engineering degree. Then I did my MTech Masters in 1985. Just for your information, the college where I studied was the one across your river, your friendly competitor college, if I may say, Jadavpur University. So, Professor Kundu, can I go forward? Okay.
Sir, shall I move to the next slide?
Yes. Can you please move to the next slide?
Okay.
Yeah, so I would like to give you a brief idea first about what the company which I work in and what it is out, what are the products and what are the competencies. Can we go next? Next. We are part of this company called Voestalpine AG. Is pronounced as Voestalpine. And just to give you, I'm sure a lot of you would not have heard of this company, but to give you a quick way to recognize this, in your steel making, in your metallurgy, you learn about a process called the LD process, which is called actually the Linz-Donawitz process. And Linz and Donawitz are actually two towns or two cities in Austria, which are basically where our steel mills are, Voestalpine steel mills are. So the LD process was invented by Voestalpine during World War II. And this was, I would say, even today, maybe 60-70% of the world's steel production is done through the LD route. So we are part of this, I would say, large steel and technology group, which has an overall revenue of 13 billion euro and about 50,000 employees as of now. We are into basically steel and steel-related industries. So apart from, let's say, the steel like roll-bond plates and clad plates and heavy plates, we are also I would say, one of the biggest suppliers of the body in white or the steel for the car bodies to large German companies like Volkswagen and Audi and Mercedes. Voestalpine is also a very large rail producer. We are also into points and crossings for the railways. So mobility is a very big part of our business. And among all this, we have the welding business. which is basically the welding consumables and welding, let's say, solutions now, with about 600 million euro of turnover and 2,300 employees globally. Next. Can we go next? Yeah. So we were talking about timelines. So we've been in the welding business since 1926. So quite similar to, let's say, a little bit older than the department, metallurgical department at Shibpur. So in another 6 years, we complete 100 years in the welding consumables business. And this company has grown with a lot of acquisitions. Some of the names are there on the screen. And we have been part of voestalpine since 2007. And the plan or the mission is to become a full welding solution provider, including welding accessories, Weltron automation, and 3D printing. I will discuss this as we go forward. Next. So what do we do in this welding consumables business? Basically, we cater to every welding application that can be thought of, at least for arc welding applications, I should say. So we are into cladding, weld cladding, we are into joint welding, maintenance and repair. We also have a range of finishing chemicals for post-weld cleaning of stainless steel beads. We are into soldering and brazing. And also the new businesses that we have launched, like automation solutions, weld care, 3D printing, and equipment. Next. voestalpine Bolo Welding has a very long tradition of innovation, and this is really what has kept us ahead of the rest and let's say one step ahead. So we have been we are quite strong on creep-resistant filler metals, mainly for use for power plant, boiler construction, fabrication, and we've been working with Indian boiler manufacturers for many years for these welding consumables. We have now developed a range of nickel-based consumables for the next generation power plant technology, which is called the advanced ultra supercritical technology. We had launched many years ago vertical down basic electrodes for cross-country pipelines. You saw the year 1926. In 1926, we launched Seelendraht, which is basically the German word for flux cord wires. And this is still the technology which basically runs the flux core wires of today. And then, of course, a lot of other things like double-coated electrodes, fully synthetic electrodes, etc. Next. So we are a multinational company, as you have probably understood by now. We have close to more than 2,000 employees in 25 countries with 2,000 distributors across the globe. Next. And in India, we've been in the country for a long time, but let's say as a company with a permanent office for the last 15 years. Mostly we are in locations Mumbai and Delhi, and we have our factory at Bhiwadi in Rajasthan, where we have we acquired this company about 6-7 years ago. And we locally manufacture welding consumables also here, apart from sourcing consumables from our 13 global factories across the globe. We also handle neighboring countries like Sri Lanka, Bangladesh, and Nepal out of India. So this is the region India that we have. Next. Some pictures of our Bhiwadi production plant. This was, as I said, this was part of Bolo Welding since 2014. We have a capacity of 10,000 tons per year of welding consumables. Mostly it's stick electrodes. We also make flux cord wires here, hard facing as well as joining flux cord wires. Next. Yeah, next. So we present ourselves in the market with three brands and three competencies. So we have the Bolo Welding brand, which is mainly the joining range of consumables. UTP maintenance is for MNR, maintenance and repair. And we have Fontargen brazing for soldering and brazing applications. Next. Can we go next? Yeah. So Bolo Welding is basically the brand under which we have about 2,000 products, which essentially cater to the joining requirements of our customers. So starting from joining of simple carbon steels to stainless steels, nickel-based, you name it. And what we would like to say about this brand is that this is basically a brand where we promote this concept of lasting connections. So this is the philosophy of this brand. This is, like you saw earlier, this has been a brand which is more than 80, 90 years old. It's been in this industry for a very, very long time. And the philosophy is that it connects both steel as well as people. Next. So Bolo Welding products are mainly basically for many industries. So I mentioned about thermal power earlier. We supply welding consumables for the nuclear industry, for wind power, mainly for the wind tower fabrication, and hydropowers for the runners of turbines and for the penstock fabrication. We also supply to the oil and gas upstream, midstream, and downstream segments, to the LNG segment for the fabrication of liquefied natural gas tanks. We supply to the automotive industry, the crane and lifting or the yellow goods industry, and for chemical processing. The consumables we have includes everything: stick electrodes, TIG rods, which is basically tungsten inert gas rods, flux core wires, which flux core wires I always say is basically the stick electrode turned outside in. So you have the wire on the tube and the flux inside the tube. And then we have MIG wires, MIG and solid wires, and submerged arc wire and flux combinations. Next. We have launched this range of accessories basically for the welders. So we have auto darkening helmets, we have clothing, safety stuff, which are basically just now being introduced into the market. Next. This is something interesting. We have launched this, let's say, I would say more of a research program right now on 3D printing, and we are following the principle of wire arc additive manufacturing. So we call it VAM. So we do not do 3D printing through powders. We have our sister companies in the group which do that, but we are focusing on wire arc additive manufacturing. So 3D printing with wire. And we have done a lot of work with research laboratories and institutions in Europe mostly on the development of the wires and the procedures for 3D printing. And we have in fact got a lot of interest even in India from industries as well as institutions for working on this. Next. This is our second brand, UTP. UTP, by the way, is a short form for a German word, Universal Tellipunkt, which is basically, it means the lowest melting point. So the eutectic point or the lowest melting point. This is the range of maintenance and repair consumables that we have. So mainly for improving the life of components by let's say a hard face layer or a corrosion resistant layer, which is done by welding. So this is our range of UTP maintenance consumables. Next. Here we cater mainly to, let's say, the steel industry, to sugar and ethanol industry, cement, mining, etc. Next. Here again, we have the entire range of consumables, including here now we have thermal spray powders, submerged arc and electroslag strip cladding, flux and strip combinations, as well as the accessories for feeding the strips. Next. Can we go next? Yeah. And
I have already moved actually.
yeah, sorry, maybe it came a little late. Okay, so we have the last brand we have is Fontargen Brazing. So we kept talking about welding, but we have another, let's say, soldering and brazing portfolio, which is mainly meant for non-ferrous alloys, mainly I would say copper. And this is our brand for that called Fontargen Brazing for all kinds of soldering and brazing applications. Next. So here we cater to mostly the car bodies, car engines, and HVAC or the air conditioning industry, as well as the tooling industry. Next. So for this, we have brazing rods, foils, paste, powders, as well as copper wires and preforms for these applications. Next. Okay, yeah, can we go next? In addition to our products, we also offer a lot of application services, which is basically, I would say, how to weld services. So we of course have the products, but many of our customers need to know how to weld and how to make sure that you get a good metallurgically sound weld. So we have a team of welding engineers and application technology experts who basically support our customers both in India as well as globally on these applications. Next. And we have a welding academy, which is essentially where we have courses for mainly for our customers and let's say in-house people like distributors and sales teams. This is not that we are not a college. We don't give any degrees or anything, but it's mainly for sharing our experience and our expertise with our customers for specific welding challenges. Next. So we have a small but strong application technology center in India. So these are some visuals from both in the office, in the workshop, as well as in the site or support to customers on training and, like I said, how to weld. Next. Okay, these are some certifications we have. I think we can skip this. Next. And we work with, a lot of industries I talked about. So these are some of our customers who we work with in India. And of course, we have many of them globally also. Next. Yes, I think this is a small interaction of maybe half an hour, 40 minutes, but please feel free to follow us on all these social media channels. You can get a lot of information about welding and about our company through these channels. Professor Kundu, can we go switch to the other presentation?
Sir, please wait a minute. We'll switch it.
Yeah. Yes. So here I would like to give just two examples of some of the, let's say, challenges that we have worked with in India and globally for two specific applications. One is on pressure vessel construction and one is on high strength steels. So I'll just take a little bit time on this, maybe another 10-15 minutes. Yeah, we can go to the next slide. So yeah, the first one is about fabrication of coke drums mainly in the refinery industry, and the second one is on high strength steel welding and how we let's say took up the challenges with some customers here. Next. Yeah, so a coke drum is what you see the picture on the right. Basically, I would say it's a long cylindrical vessel, part of refinery equipment. This is called a coke drum, and it is used for basically the residue, the bottom of barrel residue comes into this. And in service, what basically happens is that there is a lot of thermal and pressure cycling in this steel equipment, and this results in certain damages. And because of these damages, the refinery operator has to basically shut down the refinery. He has to either cut open that section and put a new one, or maybe even replace a coke drum. So I'll just show you some of the damages that actually we have taken pictures from service, and what is the solution for this. Can we go next? Next. Yeah, so these are some bulging damages which are observed on a coke drum in service. So you have on the top, on the interior surface, what you see, and on the bottom is the exterior surface. And because of these, let's say, bulging, as we call it, the refinery operator basically has to shut down the equipment and cut out this section and replace it. So in the next slide, can I just go to the next one? Okay, the material used for this coke drum is basically 1/4 chrome half moly. This is the most common material. And on your right, what you see actually is a coke drum being transported to IOCL Haldia. In fact, this picture was taken just outside Haldia refinery, where Indian fabricator had fabricated the coke drum on the west coast of India and transported across sea, and it was getting commissioned in IOCL Haldia. Next. So here the problem is that this bulging happens. What people found out in such an application is that because of the difference in the yield strength between the weld metal, the weld seams, and the parent material, so they were finding that there was this bulging happening. So what they did was that not only the welding part, but also in terms of fabrication, it was specified that for a single coke drum, that the adjoining plates, basically there would be a mapping of the plates with the yield strength, and the layout would be made in such a way that there would be a variation of not greater than 6 KSI between adjoining plates. Can we go next? So this is a schematic diagram of an actual mapping that was done by the fabricator. So you have, let's say, on the left side, which is actually the bottom, you have the nozzle forging. Then you have the dish and pipe petals. you have the shell section, the Y forging, and as you can see, the plates have been selected based on their yield strength and so that there was not too much of a variation in yield between plates on different sections next to each other. So, for example, you have for the dish and petals, you have between 470 to 450, and then towards the other side, you have in the cone section, you have 465, 458. Next. And the challenge for us as welding consumables manufacturers was that we had a limitation from the fabricator that we had to actually develop consumables. It was 1/4 chrome half moly. That's fine. That is a common consumable, but with an yield strength which was matching the base material yield strength within 10%, plus or minus 10%, and this in consumable manufacturing is not so easy. So it was a big challenge, and it needed a full R&D project to arrive at this. And this graph basically shows you the bandwidth within which we had to maintain the yield of consistently batch after batch consumables, so that it was within plus or minus 10% of the plate material yield. Next. And so you have the mapping of the plates, you have the consumables which are matching, but after that also during the fabrication there were many more constraints, like the weld finish, to make sure that there were no stress concentrations, to make sure that the weld finish was extremely good, to improve the fatigue life of the coke drum. And we talked about thermal cycling in the beginning. And also here there was an additional requirement that even temporary attachments, there had to be an approved welding procedure specification to be qualified before allowing even temporary attachment welds to be made during fabrication. Next. Can we go next? Yeah, and then there was the requirements for post-weld heat treatment. Okay, we can skip that. Can we go next? Sorry, next slide. Yeah, so that was one of the examples which I gave. I mean, that was about coke drum fabrication. Now I go to another one. This is what we call as diamond spark, which is basically our range of seamless cord wires, which we have, let's say, introduced about 3-5 years back. Mainly, it's used in many industries, mainly into oil and gas, upstream, downstream, etc. Can we go next? Yeah, so this is our, as I said, the range of seamless flux cord wires, which is using during the manufacturing. It uses both a tubular technology as well as a laser seam welded technology. And main applications are steel construction, crane and lifting, automotive, oil and gas, pipelines, and shipbuilding. Next. Can we go to the next slide? Yeah, we can skip. Please go to the next slide. Yeah, so here we have 2-3 things. The considerations are that for high tensile steel welding, one of the major problems is that the flux cord wire, a conventional flux cord wire, once you open the spool and let's say mount it on the MIG machine, there is a chance of the flux inside the tube absorbing moisture, and therefore, as you can see on the right hand side, you see the hydrogen levels. In the one on top is the conventional flux cord wire, and as you expose it, you see how the hydrogen level quickly jumps up from, let's say, 0 almost up to 8 or 10 milliliter per 100 grams. And basically, can you just go next? Yeah. So basically, with higher moisture pickup, the chance of porosity and therefore repair is very high. And this is what we wanted to avoid with this new manufacturing technology called seamless flux cord wires. And you can see the seamless wires, even over long exposures of 24, 48 hours also, the hydrogen levels are less than, let's say, 2 or 3 milliliters per 100 grams. Next. Next. Flux cord wires also is a very productive welding process. So you see here the productivity versus stick electrodes and versus, mostly basically stick electrodes. If you see the flux cord wire 1.2 millimeter, it can give you a deposition rate all the way up to about 6 to 7 kilograms per arc hour, compared to a 4 millimeter electrode, stick electrode, which can give at the most 2 kilograms per arc hour. So you have almost 3 times the deposition rate in flux cord wires compared to stick electrodes, and this is the reason flux cord wires are picking up more and more in terms of process in India versus stick electrodes. Next. So with the seamless wires, another feature that we worked on was this contact tips. So some of you who have done MIG welding in college can understand what I'm talking about. So when the wire comes out of the contact tip, there is a likelihood of the tip getting worn out because of the friction. So here, because this is a copper coated wire, and because of the way that this wire is manufactured, it's a much stiffer wire. So the tip replacement is almost 4 times longer than a conventional flux cord wire. Next. Next.
Yeah, it's being updated.
Yeah. Yeah, so these are some, this is a particularly a high-strength steel welding wire called Diamond Spark 700 MC. These are the welding parameters that we've used. Basically, it was a mixed gas argon CO2 mixture in downhand position. So this is on a 20 millimeter thickness plate. Next. Can we go to the next slide?
Yes, sir. It's being updated, I think.
Yeah. So these are the all-weld test coupon details that are there. So this is just one result, but to give you a perspective from a welding consumable development point of view, we need to do many such tests in our laboratory to actually prove these consumables before they are launched in the market. So this is just one of the tests. So here we did it in an as-welded condition, also in post-weld heat treatment with 510 for 3 hours as well as 570 for 3 hours. And these are the results that we got. Consistently, the yield was above 700 and let's say it's 25 megapascals and UTS of more than 800 megapascal, as well as impacts right up to minus 60 degrees centigrade. Next. So this is what is of interest, is that we worked with a company called L&T. They have a, let's say, a division in defense. So they were making these modular bridges for the Indian Army, and they used for the bridge construction. They use very high strength plates, steel, HSLA steel grades like 690 QL was the most common grade, and we proposed these wires mainly for the matching the steel, the strength requirements for the high strength steels, and for replacing stick electrodes, 11018M stick electrodes, to give a better productivity. Next. So this is a picture of the modular bridge. It's modular, so therefore it's folded up and then it is transported to a place where, for example, the army wants to cross over. Basically it's a temporary bridge which is created for either taking man across or even tanks across, and this entire high-strength HSLA steel was welded with this seamless flux cord wire, which I talked about earlier. And we had thicknesses ranging from 2.5 millimeter right up to 12 kilometer thick joints. And there was a 2 kilometer single pass welding, fillet weld in one of the components. Next. So these are some pictures of the fabrication. During fabrication, this is the base frame, and this wire basically gave the customer, the fabricator, all the advantages of productivity as well as low hydrogen, and low hydrogen, which means basically no porosity, and also a crack-free weld for this high tensile steel. Next. So this was basically the my last slide. So just showed you a couple of examples of real life examples of how we develop consumables and applications for industry. So one of them was refinery and one was a defense application. So Professor Kundu, this is all from my side. I'm open to questions.
Thank you very much, sir, for such an insightful presentation. Sir, if you don't mind, we would ask you a few questions from our curious viewers. Is that fine, sir?
Yes, sure.
Over to Ritam. Please ask the questions.
Thank you, sir, for your session. We have a few questions from our participants. The first question is, where to focus mainly if you're looking for a job in the welding industry?
Where to focus means what?
I mean, which subject or where to focus, which field?
See, welding is a little. First is that I think all of you in your metallurgy course, I think you have at the most maybe one chapter, one paper on welding. Am I right? See, welding is an all-encompassing field because it is not only the metallurgy part, but there is a lot of mechanical engineering. There's a lot of fabrication involved in that, and I would say it is a combination of steel making. It's a combination of mechanical metallurgy. Everything. It's got everything of what you guys learn in school, in college.
Okay, sir. The next question is, what is the opportunity for undergraduate metallurgy students like us in terms of jobs or internships in voestalpine Böhler or other companies of the voestalpine group?
We have positions which we advertise on our website. You are free to take a look and apply to that. We do not in India as of now offer internships, but if something comes up, yeah, again it will be available on our website.
Okay, sir, we have one last question. How or what was the process that took place from an undergraduate student in JU to voestalpine, and can you share your short experience for us to grow as a metallurgist?
Yeah, actually, yes, good question. Like I mentioned in the beginning, I did not do any welding metallurgy, let's say, during my undergrad course, or also even in my post graduation. My specialization was actually in powder metallurgy. But yeah, it happened that I got a job in a welding consumable manufacturer in the field of R&D. And from that, yeah, we just picked up and learned all through. But as a piece of advice, I would say there are now a lot of colleges which offer MTech courses in welding. So if you are interested in welding, I would suggest do a master's in welding and then apply to many welding companies that are there in India.
Okay, sir, thank you for your time.
Thank you, sir. Thank you very much for your time and consideration. Sir, Team Reminiscence is very grateful to you for your time.